This is lesson 1.2. So just a few vocab words before we start. First vocab word is variable. A variable is a symbol, usually a letter, that represents one or more number. An algebraic expression consists of numbers, variables, and operations. So this example of 5x plus 4 is an algebraic expression because there's numbers, variables, and an operation. And then the substitution property of equality is replacing a variable with a number. So we did that in the previous lesson where we plugged in a certain number to solve, and we'll be practicing more of that today. Okay, so the first few problems say write the phrase as an algebraic expression using x. So we're going to be writing an algebraic expression and our variable is going to be x. So letter A, and before I even get into this, I should say your lesson 1.2 notes should be open in that yellow note packet because all of this is already typed out for you. You just have to write in the answers. So letter A is 10 less than a number. So I see that less than, which we talked about yesterday, is subtraction. We have that number 10, and then a number, we're using x as our number, as our variable. That word less than, we have to flip the order. So instead of 10 minus x, we have x minus 10. That's our special rule with less than and more than. B, a number divided by 2. So I have this word divided by, so I know it's going to be division. And then we have a number, which is going to be our x, and then by 2. So we have x divided by 2. I'm going to skip number C and come back to it. I'm going to go to letter D, product of 5 and a number. I see this word product, I see this word and, 5 and a number. So it's going to be multiplication. And then we have the number 5, and then our number is our variable, which is x. So 5 times x. This is also why in 7th grade we do not use x as multiplication, because we're using the variable x, so I won't be able to tell if you're multiplying, if you're using a variable, what's going on. Letter E says the quotient of 56 and a number. I know quotient is division, so I'm finding division. And then whenever we see the word quotient, we just write the numbers and variables left to right. So this would be 56 divided by x. Letter F, 1/2 of a number. 1/2 of a number. So I see this word of, which is multiplication. 1/2 can be written as 1/2. Could also be written as 0.5. And then our number is x, so times x. Letter G is the difference of 24 and a number. Difference of 24 and a number. Difference is subtraction. And then we have 24 and a number. So we just write it left to right. 24 minus x. Okay, jumping back up to letter C. I skipped this to come back to it because it is a little bit more complicated, but we got this. Letter C says 2 less than the number of yards in a group of feet. So first of all, we have 2 less than. So we know there's going to be a 2 in it, and we know that there's going to be subtraction. Then we have to figure out, well, first of all, we know that it's going to be subtraction. Since it's less than, we have to flip them. So we know the 2 is going to come last. Then we have to figure out what this means. The number of yards in a group of feet. So if I asked you, okay, how many yards are in 3 feet? Well, there are 3 feet in every yard. So to figure out how many yards are in 3 feet, I would take 3 feet divided by 3. 3 divided by 3 would be 1. So there's 1 yard in 3 feet. If I asked you how many yards are in a group of 12 feet, well, I would take 12 divided by 3, because there's 3 feet in a yard. So this is 12 divided by 3 is 4, so that means there's 4 yards in a group of feet. So I know it's tricky, but we're going to write that as x divided by 3. And in 7th grade, we oftentimes do that bar as division. So x over 3 divided by, minus 2. All right, the next ones at the bottom, you're going to have to write these problems in. First one is A, 3z minus 10. Ooh, and it would also be very important at the top, I would write these in as well. It says evaluate the expression when x equals 3, y equals 4, and z equals 7. So what we're going to do is we're going to plug in the numbers for those variables. And then we're going to solve using order of operations. So in this case, we have 3z minus 10. Well, I know that z is 7. So I'm going to plug in a 7 for z. And then I'm going to solve. I have multiplication and subtraction here. Multiplication comes before subtraction. So I'm going to do that first. 3 times 7 is 21. And then I have minus 10. Now I just have subtraction, so I can solve. 21 minus 10 is 11. Box or circle your answer. Example B is 2y plus 4z. So again, I'm going to plug in the numbers for the variables. So we have 2 times y, and y is 4. When those variables are right next to the number, that always means multiplication. Then we have plus 4 times, and z is 7. Now I have 2 sets of multiplication, and before I can add them together, I have to multiply both. So I have 2 times 4, which is 8, plus 4 times 7, which is 28. And now I just have addition, so I can add those together. 8 plus 28 gets me 36. And I circle or I box my answer. Letter C is 5z plus x plus 4y minus 15. Make sure you write that down. And then we're going to plug in and solve. So we have 5 times z is 7 plus parentheses x is 3 plus 4 and then times y, and y is 4 minus 15. Whew, that's a long one, but we got it. So first thing I want to look for is parentheses. Got to solve what's in parentheses first. So I'm starting with this 3 plus 4 times 4. Well, I have addition and multiplication. We know that multiplication always comes first. 4 times 4 is 16. Then we can add that 3. Okay, 3 plus 16 gets us to 19. And now I can kind of add in the other parts here. I don't want to forget about them. So now we have multiplication, addition, and subtraction. Following the order of operations, we have to do multiplication first. 5 times 7 is 35, plus 19 minus 15. And I'm going to make this smaller, slide it up. Okay, then addition comes before subtraction when they're left to right, when we got both. 35 plus 19 is 54. And then we have minus 15. 54 minus 15, 39. And we circle or box our answer. On the next page, we have a story problem. So we have Jackie's car needs to be repaired. The cost of the repair is going to be $40 per hour. That's an important piece of information that we're going to want to underline and highlight. It's an additional $120 for parts. So Jackie's going to bring her car in. She has to pay $120 for parts, and then she's going to pay $40 for every hour that it takes them to work on the car. So it says, write an expression that would represent the cost of getting the car repaired if a mechanic works on it for H hours. So H is going to be our variable. So we know, like I said, it's going to be $120 no matter how many hours that they work on it. She's always going to have to pay that fee of $120 for parts. And then we have plus $40 per hour, remembering that per is multiplication. So we have 40, and then the hours are going to be represented by H. So $120 for parts, $40 per hour. Then it says find the cost if they worked on the car for 3 hours. So I'm going to take that 3 and I'm going to plug it into my variable H and solve for my total cost. So I'm taking 120 plus 40 times 3. I have addition and I have multiplication. Following PEMDAS, we always do multiplication before addition. 40 times 3, 120. And then I don't want to forget about my 120 for parts. Now I can add these two together. 120 plus 120 is 240. So now I have to write a sentence for this story problem. So it says, find the cost for 3 hours of labor. So it will cost, and your sentence doesn't have to be word for word with mine. It will cost $240. Alrighty, we're almost done. This next problem says the Read It bookstore is advertising a sale. The price of hardback books is $9.50. The price of paperback books is $4.50. And hardback, hardcover, same thing. I didn't write it. Okay. So we know every hardcover book is $9.50. Every paperback book is $4.50. So it says write an expression that can be used to find the total amount of money that's spent at the bookstore. So we're going to use H for hardcover and P for paperback. So it's $9.50 for one hardcover, but I don't know how many hardcovers I'm going to buy. So I'm going to have to multiply $9.50 by however many hardcover books that I buy. And then I'm going to add that to my total of $4.50. And then I don't know that I'm just buying one paperback book. So I'm going to multiply that by the variable P, however many paperback books I buy. So this will be the total of my hardcovers plus the total of my paperbacks to give me the total amount. So then letter B says find the total amount she spent if she bought 5 hardcover books and 4 paperback books. So now I'm just going to plug in 5 for H and I'm going to plug in 4 for P and solve. So we have $9.50 times 5 plus $4.50 times 4. I need to multiply these both together before I can add the total. So if I take $9, so forget about the 50 cents for now. $9 times 5 is going to be $45. And then 50 cents times 5 Well, if you take 50 cents 5 times, that's $2.50. So my total for hardcover is going to be $47.50. And then for paperback, if I take $4 times 4, that would be $16. 50 cents times 4, which is $2. So I get a total of $18 for paperback books. Now I'm going to add those two numbers together, 47.5 plus 18, and I'm left with $65.50. And then we always want to write a sentence. So it says find the total amount of money she spent. So we can write she spent $65.50. Again, your sentence does not have to be the same as mine. All right, and the very last problem here is an MCA practice question. It says Mrs. Nelson's class has read 50 pages from a book. The class will continue reading 15 pages per day. Which expression represents the amount of pages read after D days? So I'm going to highlight my important information, which you should always do when you're taking notes and on a test. So she's read 50 pages from a book. She's already read 50 pages. The class is going to read 15 pages per day. I see that per. I know the per is multiplication. So our 50 pages is not going to be multiplied by anything because that's already been read. That's not changing. 15 pages per day, and we know D is days. I write that as 15 times D for the amount of days. Okay, and then I look at my options here, and my answer is going to be A, because with addition, it doesn't matter which order this goes in, we're still going to get the same number, and we're going to learn about that on the next slide.